kubectl get pods. It is used to check how many pods are present over the system. Okay, let's move on to the next question. Create a new pod with nginx image. Now we have two ways to create a pod, the imperative way and the declarative way. Now what is the difference? Basically, imperative way is using the command and giving the specification into the command itself, and using the and about the declarative way, it is basically, see, when it comes to the Kubernetes, we have to extensively work with the manifest files, right? So in the declarative way, we have to specify the YAML manifest file for creation of any resources. Now we will have a look into that as well, but for now, just create a new pod using the imperative way. Okay? So you will be using the command kubectl run the pod name. Let's keep it as pod only, and then we will be specifying the image, that is image is equal to nginx. Okay, let's see if it works. Okay, the pod is created. Let's again check if it is running. You can see there is a container creating. Let's just refresh. It should be into the running state. Okay, let's wait a while. Now these pods are created by the system. We have not created this pods. It was by the code cloud itself. Let's see if it is into the running state. Yes, it is into the running state. The name of the pod is pod, and the image we have used is nginx. So this is the second command we have used using the imperative way. Now let's just copy and note it into the notepad. Okay. So clear. Let's check if the answer is right. Now, how many pods are created now? So we can see 4 pods are created. So let's select the 4 pods. That is right. What is the image used to create the new pod? Now, again, one more important command. So let's just clear kubectl get pods. And now we have to, check into, or you have to explore what specifications we have for this new pod. So for that, you will be using the command. Anyone from the chat section? Can we practice on this platform? Yeah, obviously, but it is a paid version, so I think you will need to take a subscription for that. But anyways, get pods grep image. Yeah, exactly. That is right. So you'll be using the command kubectl describe. It's not the get, but it should be describe. So describe pod. Then the name of the pod is this new pod. Just copy it. Okay, using this, now we have to check something related to the image. Let's check. See here, the image specification is given that we are using the busybox image, right? Let's check. It is right. Now again, one more command that we have used to check the contents of the pods. Okay, so just let note it down. Okay. Now, which nodes are these pods placed on? Again, one more command that we need to keep in mind is, let's just clear the screen, kubectl. Now again, you can use the kubectl describe command as well to check the details for the nodes, but we will use kubectl get pods -o wide. Using this, just name of the pod, kubectl get pods. Get pods. kubectl get pods. Name of the pod is new pod. And then -o wide. It will give more details about the pod. So let's see. The node on which it is scheduled is the control plane, right? So let's just select the control plane. I hope this simulation is very helpful for you because we are getting used to these commands, no? So how many containers are part of the pod web app? Let's just check it. kubectl get pods again. So here we have the web app pod running over here, and as a part of the web app, we have 2 containers running over that, right? So let's just select the 2 pods or the 2 containers. Now, what images are used in the new web app pod? Again, let's describe that pod. So kubectl describe pod web app, and then yeah, that is it. Let's see. There are two container as we see. So let's see what we are using for that. The first is Nginx, and for the second container we are using Agentx here. So let's just select Nginx and Agentx. That is right. What is the state of the container agent text in the pod? Obviously, we have, you can see it into the event section. So here is the event, and there is this warning that says image pull back off, right? So basically, when you are working with the Kubernetes, mostly you will be getting the issues either related to the image pull back off or the crash loop back off, or there is this image issue related to the node selectors or the node affinity, like the scheduling part. Okay, we will get into that as well into the coming sections, but till now the error it is throwing is image pullback off. Now what exactly it is? It is related to the wrong image specified into the YAML.manifest or YAML manifest files. Okay. So the error wait for it to finish the container state. What is the state? Obviously it is into the error or waiting state. Okay, let's select this again. Now, why do you think container agent text in the pod WebEx is in error? As I told you that it should be the error related to the wrong image. So let's see if we have any option. A Docker image with the name doesn't exist. Obviously, this is the first option we need to select. Now the next question is, what does the ready column in the output kubectl get pods means? Now this means it is talking about this thing. That is ready, and we have 1:2, right? So this means one container is ready out of the total two containers. Okay. So running container in pod is to total container is in pods. Okay. This should be the right option. Now let's delete. Now one more command we need to remember or we will be using is how to delete a web app pod or any pod. So for that we'll be using kubectl delete pod and the name of the pod, that is web app. Okay, the pod is deleted. Let's check. It is deleting. Okay, so let's just check if it was deleted successfully using the command kubectl get pods. So yeah, the web app pod was deleted. Let's check. Okay. Okay. Now we have used the imperative way to create a container. Now we will be using a declarative way as well. So let's see, create a new pod with name Redis and the image Redis123. Okay, so pay attention. We will be creating a YAML manifest for the pod.yaml. So let's just use the Vim editor for that, pod.yaml. Okay, now when working with any manifest file into the Kubernetes, there are four main components you need to remember. That is API version. Then there is kind. Okay, we will try to understand every component, but for now we are having API version, kind, then metadata, and at last we are having the spec. Okay. Now basically API version is used to specify the version of the pod. For now we will be using v1. Now from where does this v1 come? I'll just explain you in a bit when we are using this command that says kubectl explain pod. So using that we'll be getting the specifications for that. We will just see it in a bit. And then kind is the pod. Obviously we are using the pod here. We are trying to create a pod, so kind would be pod. Now when it comes to the metadata, we have to specify that basically this metadata means the details of your pod. So for example, we are naming this pod as, let's say, my app, or here we have to name it, create a pod name Redis. So let's give it a name Redis or rs small. Okay, and into the spec section we have to give the specification of the container that we are going to use. So we'll be using containers. Okay, and in the container section we'll be using let's give it a name. This name is for the container itself, so we can use it anything, my app. And we'll be using an image, that is Redis 123, which is specified over here. So let's just use the Redis 123. Okay. Now I think it should work. API version. Okay. Let's save this file and try to create the pod using this YAML manifest. So you will be using this command kubectl apply -f and then name of the pod, that is pod. Name of the file, that is pod.yaml. Let's see if it was created. Yes, the pod was created. Let's see. Get pods. Okay. So a pod with name Redis was created successfully, though it is having the issue with the image. But we will just try to troubleshoot it later. But for now, we have created the pod with name Redis. So let's just check. Okay, that was correct. Now the next question is, now change the image on this pod to the Redis. Okay. So basically we are having the issue with the image, right? So it is saying that the right image we need to specify should be Redis. So we will just edit it. Now one more command, I'll just explain you this. Edit pod and then name of the pod is Redis. So basically either there are two ways you can just do a modification into the image name. You know? Either you can just delete this pod, do the modification into the pod.yaml and then recreate the pod. But the easier way is to use this command, that is kubectl edit pod Redis. What this command does is it changes or it does the modification into the existing pod. How exactly it is done? So if we do the enter, you will see these are the specifications of this particular pod. Now we just have to change or replace the image name by the Redis. So here you can see the image and we'll just change it to the Redis. Let's just save this. It is edited now. It was edited on the same existing pod, that is the Redis. So let's see if it is into the running state now. kubectl get pods. Okay. As we can see, it is into the running state and the issue was solved. That is the image pullback off was solved. So let's just check. Done. So now that we have covered the theory part of the pod, it is basically a very simple concept, that is the pod. But obviously it is something which is extensively asked during the interview. So you need to be able to explain this concept when it comes to the interview, right? So we have covered the theory part and as well as the hands-on part, right? So the next concept is
file. Please open pod.yaml file again.
Sure. Just a second. Okay. Yes, tell me.
अब अगेन अगर हम अप्लाई कमांड चलाएंगे तो वो फिर से रॉन्ग इमेज के रॉन्ग पोर्ट क्रिएट कर देगा, राइट?
या एग्जैक्टली।
बट आपने जब एडिट किया है तो यहाँ पे फिर क्यों एडिट नहीं हुआ?
इसमें एडिट नहीं होगा ना, क्योंकि वो आपके एग्जिस्टिंग पॉड पे एडिट कर रहा है। बट अब ये इस पे आपको एडिट करने के लिए जैसा मैंने बताया कि आपका फर्स्ट अप्रोच रहेगा, यू हैव टू फर्स्ट डिलीट द एग्जिस्टिंग पॉड, देन यू हैव टू डू द मॉडिफिकेशन इनटू दिस pod.yaml and then you have to reapply. But when you use this kubectl edit command, then you are just doing the modification into the existing pod. Okay, you are not changing the pod.yaml that already exists. Okay.
Okay, fine, thank you.
ठीक है।
Sorry, when we are deleting, it will recreate again, right?
Sorry.
When we are deleting the pod, it will recreate again, right?
I'm really sorry, but your voice is not clear.
Okay, when we are deleting the pod, it will recreate automatically, right?
No. We are just covering. Yeah, you mentioned a good point, but we will cover it as a part of deployment. Okay? It would not be recreated. You know?
If we will update it only, so it is the concept of rolling update, right?
Mm-hmm.
If we will update the config file and apply, then it will be a rolling update, correct?
Yeah. Yes.
Actually, I have confused here, so therefore I am asking.
No issues. So guys, can we do one thing, that we can just take a Q&A session at the last, because I think the floor is getting break, no?
Yeah,
So-
correct.
Exactly. So Yeah, so let's get into the next part. Now that we have covered the concept of pod theory as well as the hands-on part, right? Now let's get into the next concept, that is the deployment. Okay. Now we have three concepts over here, that is the replication controller, replica sets, and deployment. Okay. So basically, now let's just understand the flow. Okay. We first learn about the Docker container, then we had the pod over that. Let's just name this as the uh, pod. Okay. Now on top of that, now you might be having the question that, as I guess someone from you mentioned, that the pod would not be recreated. Okay. So you might have question that, okay, this was the same work that the Docker container does, right? It is just deploying and managing the application, but it is not enabling the auto healing or auto scaling capabilities, right? So for that particular part, we are using a replication controller or the replica sets or the deployment file. Okay. So on top of pod, we have this, that is the replication controller. Now, in the last session that was hosted by the Kishale last weekend, he might have explained you about the Kubernetes architecture. Now, you might have heard about one component, that is the Kubernetes controller manager, which is residing into the control plane, right? So, what exactly controller manager does? So basically, it is responsible for managing or ensuring that desired number of pods are always present over your nodes. Okay, Kubernetes nodes. Understand? So basically, let's say this is the replication controller. Its work is to ensure that always there are number of pods or the desired number of pods present over the Kubernetes cluster. So let's just name this as the replication controller. Hmm. Okay. So we had a Docker container. On top of that, we had the pod and on top of that, we had the replication controller. Now, replication controller is enabling you the capability of auto healing. So let's say we have multiple pods running over here. Okay. So let's say we have multiple pods, and on top of that, we have a replication controller. Okay. Now, when we deployed a pod, we were able to delete it and no new created or no new replica of that particular pod was recreated, right? But when we are using the replication controller, as I said, that it has the responsibility of ensuring that the desired number of pods are present over your clusters. So in case this pod is getting destroyed, okay, now this replication controller it will do is it will just create a replica of that particular pod, just the copy of that particular pod. Okay, so it will again create it. Let's say if all these three pods are deleted, it will again create the replicas of this particular three pods. Okay, understand the concept? now now the next concept is the replica set. Now, why exactly the replica set was needed? It does the same work that of the replication controller, but the issue with the replication controller is that it is the legacy technology, like it is outdated and no one is using it nowadays. So replication controller the replica set is doing the same work that of the replication controller, but with the enhanced capabilities. Now, what exactly enhanced capability it is providing? We will just look into hands-on practical. So till then, for now, for just an overview, it is enabling now we have the new concept of labels and selectors over here. Okay. We didn't have the concept of labels and selectors inside when we were learning about the replication controller. But when it comes to the replica set, this is new concept, that is the labels and selectors. Now we will also learn about this replication or labels and selectors into the coming topics. But for now, this is something new that replica set is covering. Now again, let's say this is the replica set. Okay. Please, can you please mute the mic? I guess. Okay. So we now have the replica set, but now we will try to understand what exactly the deployment is. So deployment is basically we have a deployment on top of the replica sets or the replication controller. What exactly deployment is offering? So let's take an example. So let's say we have this application of Instagram or Facebook, right? So you might have noticed that there are frequent updates over this application. So being also for the app applications like Instagram or Facebook, it needs if like when it comes to the updates, we have to ensure that there is a zero downtime, right? Because these are the apps that are used extensively over the world, right? So for that purpose, we are using the deployment because it is used basically it is used to for the upgrade activities for the newer versions of your application. Let's say we have the V1 version of your Instagram. If you have to upgrade it to the V2, then you are using the deployment strategies. For example, we have multiple deployment strategies like blue-green deployment, or there is this canary release. Now, this is something high level, and we will be covering it into the next sessions. But for now, deployment does the work of the upgrade activities. Okay. So on top of this, we have Docker container pod, replica sets, and on top of that, we have the deployments. Okay. So now that we have understand the theory part, let's again get into the practical sessions where we will look into the different commands we'll be using as a part of these three concepts. So, okay. Replica sets. Let's just cover the replica set first. I hope the concepts are clear till now. We have just learned a very simple concepts of pods and deployment and everything. But by the time it will get more complicated. But कोई बात नहीं, तुम्हारा भाई है यहाँ पे. So I'll make it easy for you guys. Now, the first question is how many pods exist on the system. For that, we have seen the command that is kubectl get pods, or now we will use the new command that is kubectl get all. It will give the details of everything that is present over your Kubernetes cluster. So using this, now we have only one service that is running as a part of cluster IP. It is a default type of service. So basically we don't have any kind of pods running for now. Okay, so let's select the 0. The next question is how many replica sets. Again, it should be 0. Now the next question is how about now. Again, let's check kubectl get all. Now we have one replica set over here. Okay, we will again create the replica set by the declarative way as well. But for now, let's just see the easy commands that we are using for checking all these things. Sorry. How many pods are desired in the new replica set? Herein you can see there are 4 number of desired pods. Now this is something that I was talking about. That replica set is ensuring that 4 here in this case 4 pods should be always running over your Kubernetes clusters, right? So for now, let's just select the 4 pods. What is the image used to create the pods in the new replica set? Now we will just describe the replica set here using the command kubectl describe rs. RS is used for describing the replica set, and then the name of the replica set, that is this. Let's see. So what is the question? What is the image used? So let's see. Yeah, this is the image busybox777. Let's just check this. That's right. How many pods are ready into the new replica set? I guess there are 0 pods running. So we should select 0. We will troubleshoot this as well. We are having the issue with events. We will have a look into that as well. Yeah, there is this image pullback off again. So we will do the modification into the image as well. So for now, why do you think the pods are not ready? As discussed, it is related to the image. So the image busybox doesn't exist. Okay. Now delete any one of the 4 pods. Okay. Now this is the magic of the replica sets. Okay. So let's just try to delete any of the pod. Kubectl get pods. And let's just delete one pod from this. let's just copy kubectl. Now this is the command we will be using, kubectl delete pod. Oh, delete pod and the name of the pod. So the pod is deleted. Now guys, what do you think what will happen? Will we have 3 pods over here, or will we have 4 pods over here? Anyone from the comment section, or sorry, the chat section? We will be having the 4 pods, right? Let's just verify if we have 4 pods running over here. Now this is what I was talking about, that replica set will always ensure that 4 number of pods will be present over the Kubernetes cluster. So how many pods exist now? Again, 4. Why are there still 4 pods? Again, we have discussed the reason, because replica sets ensure that desired number of pods are always running. Okay. Create a replica set using the replica set definition1 file at this. So I guess we have a file over here. Let's see. Yeah, we have 3 files and we need to create a replica set using definition1. So let's just try to create kubectl apply -f replica set 1. Let's just do the dry run, no? So one more new command for you guys. If you have to do the dry run before actually creating a resource, so you will just use dry run is equal to client. Okay, a very simple command, replica set 1. Oh, it should be YAML again. .yaml. Okay, let's try to run it. Okay, now we have an error that says resource mapping not found for name replica set 1. Okay, namespace from the no matches for kind replica set in version 1. Okay, now anyone from the chat section could figure out what exactly the issue is? Just a hint, it should be the issue with the API version. So anyone from the chat forgot to note down commands? Oh, okay, I'll prepare it. But till then,
can you open the YAML file?
yeah, we will open the YAML file. Okay. So vim replica set 1 YAML. Okay. Okay. What should be the issue with this YAML file? Anyone? In the chat, app v1 API version, right? So yeah, exactly, Manoj, you are right. So basically, when you are working with the replica set, again, I'll just use this command. So API, from where does this API version come? For that, you can use kubectl explain and replica set, that is rs, explain rs. So here you can see group apps and the version is equal to v1. So you have to use apps/v1, not only the v1. Okay. So we will do the modification into the replica or the YAML manifest using the I. Let's just do apps/. Okay. Now I think it should work. kubectl again apply -f replica set 1.yaml. Okay, I think it should work. Now the replica set is created. Let's just check the status. Get rs. So we have created the replica set with name replica set 1. Let's check if it is right. Yep. Now fix the issue. Okay, we have 0 pods running over here. So fix the issue in replica set 2 as well and create the replica set using it. Now it is asking us to create a replica set using this particular file, that is the 2. Let's just clear the screen. So again, we will use the dry run kubectl apply -f replica set 2 -- dry run is equal to client. Okay. So it is created. Okay. There's no issue with the kubectl apply -, or let's just check the YAML manifest. No, kubectl replica set 2. Okay, let's see. Oh, I got the issue. Anyone from the chat section again? If anyone can figure out what exactly the issue in this manifest is.
Yeah, that image and the app name, Nginx, spelling mistake. Name,
Uh, which one?
that's not correct. Containers the name Nginx,
No,
image
no, no.
equal to Nginx. Okay.
Nice try, nice try. But actually, that's not that issue. The issue with this is the selectors and labels. Now you might see that selectors here is the front end, but here it is labels, it is Nginx, right? Now I have not explained you the concept of labels and selectors. Basically what exactly happens is, see, whenever a new pods needs to be created, now we have seen that replica set is enabling you the capabilities of, recreating the pod if it is destroyed, right? So how it will understand that what or which replica of the pod should be created. So it would be done using these selectors and labels. Okay. Now again, it would be used into the service concept as well. We will have a deeper or we will have a detailed look over this concept. But for now, the issue with this YAML manifest is that this is a mismatch.
Yeah,
So
front
this
end
tier
and
also
back
front
end.
end.
It should be front end. Yes. So doing this modification, I guess the issue should be solved. Let's just try it. Kubectl apply -f. What was it? Replica set 2. Let's see. We have created it successfully with the name replica set 2. Okay, let's check. Yeah, we were right. So most probably or it was the issue with the selectors and labels now. Now again, delete the two newly created. We will just delete it using kubectl. If you have to delete multiple resources, then you can just use the space between them. So kubectl delete rs, and let's just give the names and a space, then the next -2. Okay, it is deleted. Let's check. Till here, the concepts are very easy. Now we will also try to create a replica set or the deployment using the declarative way also. Okay. So for now, the next question is fix the original replica set this to use correct busybox. Okay, kubectl get rs. So let's try to troubleshoot the issue with the replica set. Now we will be using the edit command. Okay, kubectl edit rs and then the name of the rs. Okay. We will just simply replace the image. Let's see if we can find something. It should be present in the specs section. Yeah, here. It should be replaced with the normal busybox. So now the issue will be solved, and the containers we see into the error state, it should be running over here. So kubectl get pods. Okay, now here here the pods are still into the error, that is the image pullback off, right? But now we have to understand that these are the old pods. For the new pods, we have to delete these particular pods, right? So we will just first delete this particular pods, that is kubectl delete pod and all these pods. We will just delete every pod present over here. Copy, paste, I guess fix. Okay. Now we will delete this and let's see if new pods are recreated and it is into the running state. Okay. kubectl pods get pods. Okay. Yes, they are into the running state now. So the issue is solved. What did you do? You just change and do the modification into the image and then you just deleted and recreated the pod. This is the magic of the replica sets. Now the next is scale the replica set. Okay, one more new command we will be using. How to exactly? Now this is where the auto scaling comes into the picture. Obviously, here we are doing the scaling manually, but for the auto scaling, we have different commands. We will have a look into that at the later section. But for now, let's just scale the replica set manually. So for that, we will be using the command kubectl. The question is scale the replica set to 5 pods. Use scale command. Okay. So kubectl scale rs. What is the name of the replica set? Again, I forgot. kubectl get rs. Okay. kubectl scale and name of the replica set, and then we will be using the flag replicas is equal to 5. Makes sense. Here the new concept is the scaling. It should be kubectl. Okay. Now we are using this command kubectl scale. What does this command means? That we have, for now we have 4 pods running, right? But now we have to scale it to 5 pods. So what we are using is kubectl scale, and we are just doing the modification into the scale. Okay, let's just run this and let's see how many pods we have now. Get pods. So now 1, 2, 3, 4, 5. We have 5 pods. Okay, very simple concepts. Now scale the replica set down to 0. Again, we will just scale down it. Okay, it is scaled down. Okay. So we have understand the concept of replica set as well. I think it's time to get into the concept of deployments. Okay. Submit.
And this is desired and current state. It is showing both are 4.
Sorry.
Desired and the current state. Both it is showing 4 only.
No, it was showing 5. No.
No. The before replica set using that it was showing both are 4 only.
Sorry, I'm not getting your point.
Before we are running that replica set command, it was showing both current and desired 4 only.
Yeah, exactly.
Because current and desired it cannot be the same, right? So why we are it should be both are same.
Could you please type it, because actually your voice is so.
Okay. No. This desired and current state both are showing 4. So it can be the same.
Yeah, it can be same, because see, you have three types or 3 components. That is the desired one, desired. Then you have like running one, and I don't know the third one. I guess it is the current, right?
Current is.
Yeah, exactly. So the desired, like, it just means that all the pods are running into the running state. All the desired pods, that is the 4 pods, are into the running state. So it should not be the issue.
Okay, because current replica, if you are giving 2, it should be current 2, and the desired, what is the maximum we are setting? That is the desired, right?
Yeah. So see, the command we use as replicas is equal to 5, right? So this 5 is equal to desired. Okay, that means that 5 pods should be always running over the node. Got my point?
That is maximum, right?
Exactly, that is the maximum.
Okay.
In fact, that is not the maximum, that is the desired. No, like, we can't have 3 or 4 pods. We just have to have 5 pods over the node. Okay?
Okay.
That is maximum as well as minimum.
There is a possibility to set minimum max pods here.
Yeah, we have the possibility for that. I don't remember the command, but we have this. We have to set maximum and the minimum and the desired in flag while running the replicas. So let's just see into that as well. Give me a command for setting minimum is equal to 3, maximum is equal to 5, and desired is equal to, let's say, 3 pods in Kubernetes. So the command is, see, this is how you can do it. You have to specify minimum 3, maximum 5, and there is this CPU percentage. So this is how your auto scaling works, right? I was talking about the auto scaling. So this is the command: kubectl auto scale deployment, and minimum should be 3, maximum should be 5. and it will depend on the CPU utilization. Let's say your CPU utilization hits the threshold of 80%, so a new pod will be created. You can just set it to 10 as well. Okay. So
And how can we setting the same within file as well? Like any possibility?
yeah, we can do it into the YAML manifest as well. We just have to give this flags into the YAML manifest.
Can you show the same?
Just give me a YAML manifest for that.
Okay, so desired means it will be always running that particular number.
Yeah, desired is something that should be present over the Kubernetes at a time. Okay.
Okay.
See, this is minimum replicas is equal to 3, maximum replicas is equal to 5, and there is this resource limits as well. I guess we
Okay,
have
so
here.
inside the horizontal pod scaling, na HPA.
Yeah, exactly. This is the horizontal pod autoscaler. We also have the vertical one, but maybe we can discuss it later, no? So let's get over with the deployment part. Now herein we will try to create a deployment file using the declarative approach. Okay? So we still have 45 people. That's great. Let's see how many of you remain till the end, because we will be deploying application over the EKS at the end. So okay, so how many pods exist on the system? Again, let me just refresh this. So kubectl, again we will use kubectl get all. Okay. Now you might think that these commands are repeating, but this is how you will get used to the Kubernetes commands. No. So we have only one service, and for now we have 0 pods. Again, okay, how many replica sets? Again 0. How many deployments? Again 0. Now, how many deployments exist on now? Let's check. We have one deployment over here. That is this. Okay? Deployment. We have one replica set as well, one service, and then we have 1, 2, 3, 4, 4 pods. So how many replica sets? Again, it should be 1. How many pods exist? That is 4. Out of all the existing pods, how many of them are ready? So nothing is ready. You can see 0, 0, 0, 0. In fact, you can see over here as well. That is 4 desired. There is 0 ready. Okay. So the next is, what is the image used to create the pod in the new deployment? Okay, let's just clear the screen. Why is it? Can't we expand the screen? Anyways, so what is the image used to create the deployment? Again, we will be using the describe command. Describe deployment, and then the name of the deployment. Now, what was the name of the deployment?
We used Nginx, no?
Not sure. Let's just verify. No, we have the name front-end deployment. So kubectl describe deployment, and then the name of the deployment. That is okay. Describe. Okay, sorry. Describe. Okay. So the image we are using is busybox 888. This one. What do you think the deployment? Why do you think the deployment is not ready? Let's just see the events. So what was the error we were getting? Let's just see the pods again. Clear kubectl get pods. We have again the issue with the image. So this should be the issue with the wrong image specification into the YAML manifest. Create a new deployment using the deployment definition one file. Let's see if we have the file over here. Yeah, we have. Let's just try to kubectl apply -f deployment. So it is created. Okay, we got an error over here. So the error from the server error when creating deployment in version v1 cannot be handled as the deployment. Okay, Now, okay, in the chat section again, I'll just open the YAML manifest. Just tell me what exactly the issue should be. You have looked into the error as well. So anyone from the chat section? Mm, deployment, yeah. Jetty Nagateja, exactly. This is the issue with the wrong, what we can say that, syntax? Exactly. So it should be capital D. Okay. The YAML manifest are always your indentation sensitive and the syntax sensitive as well. So this should be the capital D. Okay. A very minor issue, but anyways, you understand how exactly to troubleshoot. No. In the error itself, it is just saying that error when creating deployment. See, the D is small. Sorry, here you can see the D is small. Here, no kind deployment is registered for version. Okay. So let's try to create it once again. It is created. Let's check it. Create a new deployment within the below attributes. Okay, now here we will create a deployment using the declarative approach. Okay. Now stay with me here. Let's try to create a YAML manifest for this. vim deployment.yaml. Okay. As I said that we have 4 main components, that is the API version, then we have kind, we have metadata, and then we have spec. Okay, let's try to write it one by one. For the deployment, we are using apps/v1. In the kind, we are using deployment. Okay. In the metadata, we have to give the specification of the deployment. Let's say the name itself. So here we have been given the name of the deployment. So just copy name. Oh, sorry, name and then the deployment name. Okay. Now, just pay attention. Now, in the spec section, in the pod section, we have just seen that we just have to specify the details of the containers over here. But when we are working with the deployment over here, we just saw the flow, right? We are having the container, pod, replication controller or the replica set, and the deployment itself, right? So for that, we have to use a template over here. Now that template will cover all the details of your pod and the your container as well. Okay. So for that, we'll be using template. In the template, we'll be using metadata. Let's just use metadata. Okay. We'll specify the name of the pod. Here, this name specifies the name of the pod. Okay. So anything. Let's again give it the HTTP front end. Okay. Now here we are going to cover the concept of labels and selectors. So we will just specify the labels. Is it the labels or the label? We will just verify it again. Labels?
Yes.
Okay. So once the label says, let's just specify it. Let's say app is equal to front end. Okay. Again. So we have specified or we have given a specific label to this particular pod. Okay. These are the specs. Till now we are writing the specs for the pod itself. The name of the pod is this and the label it is carrying is this. Okay. App is equal to, this is the key value pair. Now once the labels are created, then we will give the specification for the what we can say the container. Okay. So let's just write the specs. Yeah, so let's just write the specs for the container itself. This specs was for the pod, and now we are going to write the specs for the container. So let's just use the containers again, as it is a string. So we will be using name of the container, anything. We can do my app. Okay, and we have to specify the image. I hope it is easy for you guys. Image. Okay, we have this image. No, we have been given into the question that we have to use this particular image. Okay. So we have given the image as well.
We need to give replicas 3, right? Before template.
No, exactly. We can specify replica anywhere, like before that or after that, anyways. That doesn't matter. But after the template, we will use the selectors. Okay. Now, why these selectors are used? These selectors will match the label that is specified for the particular pod. Okay. So once you are using the selectors, you have to specify the match labels. Now, I'm not sure the syntax is correct. I
Correct.
think it should be. Okay. So uh, match labels is labels is equal to labels is equal to app. Let's just copy this now. Copy and then paste it. Okay. I think we are right till here. And then now one more component into the spec section. Till now we have, see, I'll just give you a brief overview. We are specifying the metadata of the pod and the container inside the template. Okay. Once it is done, now we will be, doing the match label with the labels of the pod. Now, once it is done, then we have to specify the replicas. Okay. Now let's say replica should be 3. Here it is, the 3. Now I guess everything is correct till here. API version, or anyways, if there is an issue, then we will just troubleshoot it. No?
Selector is like S is not mentioned. S is extra S. Selector only, not selectors.
Oh, okay. Thanks a lot. And I guess everything is right now. Or I have the note for that. We will just cross verify it once.
Specification also
So
written wrong.
specifications image.
Uh,
Okay, I guess it is right. Let's just see that if it works. Okay. So let's save the file. Let's try to kubectl apply -f and the deployment.yaml. Oh, sorry, deployment. Apply -f deploy.
Your file name is wrong.
Deployment.yaml.
Deployment.
Oh, okay. Let's see. Okay, we have the issue with spec selectors match labels of type string. Okay, let's try to figure it out. Deployment. Okay. So it is showing the error.
From the space specification. Remove the S. Only space. Spec.
Oh, sorry. So here we have spec only. That's right. And apart from this, I guess that should be correct. API version spec selector. Okay, let's try to run it. Anyways, guys, you don't have to remember all these things. You can just refer to the official documentation, because see, this is not an programming language, right? It is just you have to just take the reference from the official website. So let's again try to create the deployment file. Again, we have the issue with the match labels. Match labels app, or let's just copy this now. When deployment. Okay. Anyone from the chat section? I would require your help. Metadata name spec. There should be some indentation error into this. I think something is missing. Match labels, label app. Match labels. Oh. Got it. We have specified this extra label over here. We are already doing the match label, and we don't need to specify labels over here. Okay, that was the only mistake we did. Let's see. Hope. Finally. So let's just verify if it was successfully created. kubectl get deployment. Yeah. So the deployment with name front-end deployment was created. Okay. Let's just check. Okay. Now again, next. We have successfully completed the deployment as well. So now we have completed, or we have understand the concept of pods, replication controller, replica sets, and deployments. So we are good with that. Now let's try to understand the next concept, that is the service. Very important concept when it comes to the Kubernetes part. Okay, and it is the most extensively covered concept in while when it comes to the interview. Okay, so we have the concept of service. Now, obviously, we have to look into the why aspect of it, like why exactly the service was needed, right? So till here, we understood why exactly the deployment was needed, but till now we didn't have a look on how exactly to expose our application to the outside world, right? We just did the deployment of your application using the deployment or the replica set, but how exactly to expose it to the outside world? Now this is done using the service. Okay. Now service is mitigating three main issues or offering you the three main features. The first one is, see, let's say you have, first I have already explained that you can expose your application to the outside world. The next one is that, let's say you have a multi-tier application that is having the front end, back end, and then you are also having the database as well. Okay. So what if you have to do the internal routing or internal network routing between these services, or you have to establish the connection or networking between these services? Now this is something which is which service solves, right? So the first thing service solves is it is used to expose the application to the outside world. The next is it is used to do the internal routing between the services inside the cluster itself, right? And the third and the most important part is, now let's see. See, let's say we have the application, or we have the application of Amazon.com. Okay? So they might have the hundreds and thousands of nodes and pods in their Kubernetes clusters, right? Now it is never, or you might have never seen that they are just sharing the IPs of their application and they're asking their users to access their application over that particular IPs, right? They have a specific domain for that, that is www.amazon.com. Okay. So basically service is solving the issue of your service discovery. Now what exactly the service discovery is, right? So we have seen that using the deployment, we are ensuring that a desired number of states pods are always running over the cluster. But what happens is, let's say we have this multiple pods. Okay, this particular pod should be having a unique IP address 10.00, anything like that. But when it gets destroyed, it will come up. Obviously, the replica of this pod will come up, but it will be having the different IP address. Okay. Now, how exactly this IP, or how exactly the Kubernetes will understand that, okay, this is the pod that you need to host your application on. Okay. Now, this is where the concept of service discovery or the match labels and selectors come into the place. Okay. Now let's say, even if this particular pod is going down or getting destroyed, this will come up with a different IP address. But let's say if while writing the deployment file, right, we have specified the labels and match labels or the selectors. So using that particular thing, this particular pod will be recreated with different IP address, but with the same match labels or the same labels and selectors. This is how your service will be able to understand, okay, this is the pod where I want to host our application. Getting my point? So let's say we have this user. We have the user outside this Kubernetes cluster trying to access this application. Let's give the arrow. Okay, trying to access this application. Now, to access this application, here you will be having a service. Now we are having different type of services. We will just cover it in a bit. But for now, we will be having a service implemented over here. Once this service, once you are accessing this service then route the traffic to this particular pods. Okay. Now internally it is done using the cluster IP. Let's try to understand what exactly and how many types of services are there. We have three types of services, that is cluster IP, then we have node port, and at last we have load balancer as well. Now we might be having more services as well, but for now, these are the three main services that we will have a look into. So the first one is the cluster IP, right? Now cluster IP is the default type of IP. So whenever a pod is created, it is by default created with the cluster IP type of service. For example, when we were using the command get kubectl get services or all, right, we were saying that there is this cluster IP type of service present over the system. So this is basically a default type of service that is present. Now, why exactly it is needed? It is used, as I have already said, that let's say we have a multi-tier application where front end, let's say this is front end, this is back end, and this is database. Front end needs to communicate with the database, oh sorry, back end, and back end needs to communicate with the database, right? So this is where for the internal routing, a clustered IP type of service is used. What if we have to expose this application to the internet or to the outside world? This is where the concept of node port will come into the picture. Okay? So node port is basically an IP, let's say 192.0.0.0 colon 30,001. Now here you need to understand that node port is having a specific range, that is I guess 30,000 to somewhere between 30,000 to 32,767, I guess. Correct me if I'm wrong. So yeah, I guess that's the desired IP range. So anyways, this is for exposing our application to the outside world. We'll be using the node port type of service. And one more thing we are having is, let's say, obviously, now as I said that this node port is having the IP address, but you will just not go and give the user an IP address to access your application. You are having a specific domain for that, right? So to enable that particular thing, you are using the load balancer type of service. Okay? You got the difference between these three type of services, that is the cluster IP, which is used for the internal routing. Then we have node port, which is used for the exposing your application to your organization. Okay? Basically, it is mostly used for exposing it inside your organization. And then you have this load balancer type of service. Okay? Now you have understand the concept here. Let's get into the practical part. So let it start. Just give me a second. I'll just have a water. Service. So it should be one. The next question is, yeah, that is the default service created by Kubernetes at launch. Kubernetes at launch. What is the type of the default Kubernetes service? Obviously, it is cluster IP. The next question is, what is the target port configured? Okay, so for that, we will just describe this particular Kubernetes service. So Kubernetes describe, explain me service SVC and the name of the service. This. Let's see the target port. Okay, one more concept we need to understand is this target port and the node port. Okay, so when we are using the services, we have these three ports enabled. I'll just tell you in a brief. So for now, we have the 6443. Okay. Now let's understand the concept of target port and the node port. Okay. Now whenever a user is accessing your application or Kubernetes cluster, let's say it is using a node port service. Okay. Just this is the node port service. Okay. Let me write NP. Okay. Now this node port will do the routing internally, and once it is done, it will go to the port. Okay. So let's say this is the service to which I want to get or access. So let's say it is using the port. Okay. It is a type of port we are exposing when specifying the service. Okay. Now once we get the request from node port to the port, and then from this port, the traffic would be routed or the networking would be routed to the target port. Okay. Now target port is something on which your application is listening to. Okay. So I hope you guys understand the difference between these three. So for now, how many labels are configured? Okay. Now one more new command we will see is show labels. So Kubernetes kuber Kubernetes kubectl kubectl uh, Kubernetes service create svc. Then we have Kubernetes, and then we will be using the flag that is show label. Okay, let's see how many labels we have. Okay, is it the labels? Yeah, it is the labels. So we have, for now we have one and two labels. Okay, let's see if it is right. This is the comma between API server and the Kubernetes. Okay, so this is new command that is using the flag show labels. You will be able to check how many labels are present, how many endpoints are attached. Again, describe as we see. Okay, you can always check the labels here as well. That is 1 and 2. Now again, the endpoints, we have one endpoint here. How many deployments exist on the system now? Let's see, kubectl get all. So we have one deployment, that is this. What is the image used to create the pod into the deployment? Again, kubectl describe. Now you guys must be just a second. kubectl, okay. So kubectl describe deployment, and the name of the deployment is simple web app deployment. Let's see what we have to check the image. So we are using Code Cloud Simple Web App Red. That is the correct image we are using. Are you able to access the web app UI? Try to access the web app application UI using the tab Simple Web App UI above the terminal. Above the terminal. Is it this? Okay, we are not able to access. There is this 502 bad gateway. So okay, let's try to troubleshoot it. No, we are not able to access it. So create a new service to access the web application using service definition file. Okay, now let's try to write a service definition file again. Okay, so we'll use it. We will do it using the declarative way. Or it is saying that a file already exists. Okay, let's see. We have a service definition file. Let's explore the content. So service. Okay, so it is already present and we just have to fill in the blanks. Okay, easy. Or I'll just give you an overview about this service file again. No, so again, the API version kind metadata, it is as same as that. And then in the spec section, you will be exposing the ports. As I have already told that there are 3 ports, that node port, and the target port. Into the node port, we will just fill in the blanks. No, so for the name, we are having web app service. Then the port section type is the node port. Node port. Till then, we will just have a look into a Kubernetes cluster. No, if it is created. Yeah, it was created. 22 resources added, and we were able to cluster name is EKS cluster. So, anyways, name selector name is simple web app. Target port is 8080. Easy. Again, the port is 8080 and the node port is 30,080. Now let's understand the node port through which you will access, a user will access the application is 30,080. Then the port on which the node port will route the traffic is the 8080, and this port will route the traffic to the target port, that is the application is listening to, that is 8080. Okay.
So basically, one question. Basically, every time when you give the URL, you need to enter 3080, I mean 30,080 at the end, right?
You have to enter this node port. Okay, 30,080.
Yeah. Okay.
Yeah. So let's just save the file. Let's again apply kubectl apply -f, and then we have service definition YAML file. Okay, It is created. Let's try to access our application. It is accessible. Hello from simple web app. Anyways, it is done. So we have again covered the concept of service as well. Oh, one question is remaining. Access the, yeah, that is right. So I hope this concept of service is also, yes.
There is something related with protocol, right? Within the service file.
Mm,
Protocol
let me
like
just,
TCP and
huh,
we are mentioning. What is this?
exactly. See, it comes into the load balancer type of services. Basically, see, when you are creating a load balancer, then you have to, use the target group as well for the listening purpose, right? So in the target groups, you are doing this. For example, I'll just see, this is the load balancer, and while creating the load balancer, you will create a target group. Now, while creating the target group, see, this is the protocol TCP, and this is the port 80. Now, this is something that it is referring to.
Okay,
Okay.
okay, okay. And one more question.
Mhm.
How the service like load balancer and cluster IP is different from Ingress?
That is something I would have to look into because I didn't got a chance to work over the ingress yet. But obviously, I'll plan a session related to the ingress as well.
Because we are
Okay.
setting the Ingress over the services, right?
No, sorry, I'm not aware of that concept.
Okay, okay, no issue.
Maybe in the latter at the end, anyone from the chat section will explain if he has the idea.
Okay, no
That
problem.
would be
Thank
great.
you.
Thank you, Anurag. So we have covered the Kubernetes service part as well. Now, a very important concept we will cover. Obviously, I understand that the session is getting lengthy, but I hope it is helpful for you guys. So the next concept we will be understanding is, obviously we have covered the labels and selectors as well. So we will just keep it out. I hope you understand the labels and selectors as well. Now that we have covered all this concept, we will get into the scheduling part. Okay. Now this is very important for you to understand the scheduling, because on day-to-day basis you have to upgrade your Kubernetes clusters and you have to do a lot of scheduling part over your nodes and pods, right? So what exactly, let's just take an example. Okay, so for example, you have to upgrade your Kubernetes cluster, right? You have multiple nodes present your over your Kubernetes cluster, and then you have multiple pods as well. Now for the upgradation activity, what is required is you would require a node, an empty node. It should not have any particular pods inside it, right? So for that purpose, we are having this concepts of taints and tolerations, and then we will be looking into the node selectors and node affinity as well. Okay. Now I'll give you a very simple example. Let's say, okay. Let me just delete. Oh, just understand the flow. Okay. So now on top of the deployment, we have the service enabled over here. Okay. So now I was talking about the example, no? Just a second. Just give me a second. Just simply use or apply Odomos over me, right? So applying this Odomos will protect myself from this particular mosquito, right? So now similarly take an example of Kubernetes cluster. Let's say this is a node, okay? This is a node and this is a pod. Now, what if I don't want any pod to be scheduled over this particular node, right? So I'll just apply a Odomos over here. In technical terms, this Odomos is called as your taints. Okay? So I'll just apply a taint over here, and using that, this particular pod or the mosquito won't be able to schedule, and it will just schedule over other node. Got my point? So this is what the taints and tolerations is. Basically, you just have to it comes into the picture when you have the requirement that you don't want any pod to be scheduled over your particular node. Okay. Now what happens is sometimes this mosquito can be tolerant to that particular Odomos, right? So this is where the tolerations comes into the place, where if it is immune to that particular odomos, it can still get into the pod or the node. Okay. So this is called as the taint and toleration. Now there are three taints and there are basically the taint types. That is, if I can just write it down into the notes. So basically there are three types of taint types. That is the node schedule. Okay, we will try to understand the differences as well. Prefer node schedule. This is where your Kubernetes gets a bit tricky. Koi baat nahi. I'm here. So prefer no schedule again, and then there is this no execute. Okay, these are the taint types. Taint types or the taint effects types. Now what exactly this is? Now let's consider an example where basically this no schedule is used when for the new pods. See, let's say you have the requirement where you have this particular node which is extensively used for scheduling your or for scheduling obviously your Java applications, let's say, okay? And you don't want any other applications to be scheduled over that particular pod. Okay? Or let's say one more example, that let's say your node is getting out of memory and you don't want any new node or any new pod to be get scheduled over that particular node. So this is where you will use no schedule type of taint. Okay? But when it comes to the prefer no schedule, it doesn't give you guarantee. It will just check. It will just prefer not to schedule over here. But if that particular pod doesn't get any other space, it will just schedule itself. Okay? Basically, it doesn't give you a guarantee that it won't be scheduled over that particular node. And the third type of taint type is no execute. Now it is extensively used while the upgradation activities. For upgradation, you want your node to be empty and you don't want any pod to be present over your node. So most of the times, a lot of pods must be present already into your node, right? So first you have to drain that particular nodes or the pods from that node. And then you also have to restrict new nodes to be scheduled over that particular node, right? New pods to be scheduled over that particular nodes, right? So in that case, you will be using no execute type of taint type, taint effect. Okay? I hope the concept is clear between the taint and tolerations and the taint effect types. So let's just do a small hands-on over that again. Again, I guess it should be present into the scheduling part, that is taints and tolerations. Okay? Let's do a hands-on real quick. Or I'll just explain a node selector and node affinity at the same time, then we will just go ahead with the application deployment, because I guess there is this time constraint now. It is already 1.5 hours, so
Sir, tainted tolerance and affinity and non-affinity, it's based on pod or node based? Like where we are mentioning.
Basically, see, okay, that's a good point. I forgot to mention it. See, taint is something you will be applying. Could you please mute? So taint is something you will be applying over the node. Okay? So let's say we have tainted this node. Okay? And now we have the pod. So if this pod is, or if this node is tainted, this pod won't be able to get scheduled over this. But what if we have applied the tolerations over this pod? Okay? As I said, that mosquito might be immune to this particular taint. Okay? So taint is used over the node, whereas toleration is applied over the pods. Okay? If it has the toleration to that particular taint, this pod can still get scheduled over that particular node. Now, as I gave you the example that I want only the Java applications to be applied or scheduled over that particular node, right? So I'll just give this particular pod the toleration that is Java. Okay? So in that way, only the pods which are having the Java configurations or the applications will be able to schedule over this particular node. Getting my point?
Okay, noted.
Okay?
And
so now that
affinity and non-affinity, it will schedule on.
Yeah, so we will cover this section, this part now. So what exactly nodes affinity and node selector is? Now, obviously, we have to understand the Y aspect. Now, the limitation with tents and toleration is that you might have noticed that it is only used to restrict any particular pod to get scheduled over particular node, right? It is not giving any such instance that okay, schedule that particular pod over this particular node, right? We haven't seen something like this. It is just restricting this particular pods. But this is where the concept of node selector and node affinity is used. Okay? So basically, what let's say we have, let me just take an example. Let's say we have this big data app, okay, where a very application with huge database is deployed. Okay, now you just want that particular pods to be scheduled over this particular node. Okay, so what you will do is you will just while creating a deployment.yaml, you will just give the specifications of node selector and the name of that particular node. So in that case, this particular pod, let's say this is the pod, a big data app. This particular pod will be scheduled only in this particular node. Getting my point? So this is what node selector is, but now there is this node affinity as well. Now what enhanced capabilities node affinity is offering you? Now basically, as we have seen that in the node selector, what if we have multiple nodes? Okay, what you have? What if we have multiple nodes? So, and what if I have a condition? Let's say this pod can either be scheduled over this pod, this node, or the this node, but not into the this node. Into the node selector, we are not getting that particular capabilities where we can specify a condition. Okay, but into the node affinity, we can either let's say we can either schedule a pod on pod node A or node B, but I don't want to schedule over node C, so it will just schedule over this. So for that, we have the operators into that. So we have three type of operators. That is the exist. Then there is this, I guess, equals. Yeah, that is equals. And the third one is, I guess, not equal or not in. I'm not sure, but these are the three type of node affinity we are using. Now, again, there are two types of node affinities. That is, did I write somewhere? Because see, there are two types of node affinities. That is, no required schedule. I'm not remembering the name.
Required during scheduling, preferred during execution.
Exactly. Yes. So preferred, yeah, that is required during the scheduling and ignored during the I guess execution. And there
Right.
is second that is preferred during the scheduling and ignored during the execution. Now, what exactly this means? Okay. So required during the scheduling means that that particular pod will always be scheduled over specific node that we are assigning it to. Okay. But again, the required that the second type is that is required during the scheduling. That means that it doesn't give a guarantee. It can or it cannot be scheduled over that particular node. Okay, that is the basic difference. I hope the concept of node affinity, node selector, then what we have, tents and toleration is clear. Now, in a very short time of period, we will just deploy a EKS cluster or EKS application over our cluster. Okay. Guys, I hope the concepts are clear because these are the concepts that are extensively covered into your Kubernetes cluster. One concept we are remained is that is the Kubernetes volume. Now, obviously, we will cover it as well. And obviously, as I have said, that we would need at least 3 to 4, or I guess more 2 to 3 session to cover all the topics of the Kubernetes. So in the next session, we will be covering the monitoring and the logging part, and after that, we will be covering the concept of security aspect. Okay. So for now, I hope everything is clear to you. Now we will just deploy a very small application, a very easy application. We have the Kubernetes cluster ready. I guess it should be disconnected. So, okay. Now again, our Kubernetes cluster is ready, but we have to run one command. That is, I might have written it somewhere. Yeah, this is the command that we need to use. This command is specifically used to establish a communication between your EKS cluster and your what we can say, and your like the nodes. Okay. So we will just use this command real quick. There should be no editing over here.